Alright, this is 3.4, the last section of Chapter 3, Quadratic and Power Models. So this starts off modeling quadratic function from 3 points if you know the points on the graph. So if we know this one's talking about quadratics, like x squareds, something that looks like ax squared plus bx plus c, that's what we mean by a quadratic. Alright, if we're wanting to come up with an equation that has that form and we know 3 points, we can come up with it exactly. So I'm going to pull up the calculator, put these 3 points in there, and we'll come up with the equation of the parabola that passes through those points. So I'm putting the points in here. I got 0, 5, 4, 13, and negative 2, 25. Alright, so I have the 3 points in my calculator under L1 and L2. And just like before, we go to stat and then come over to calc like we're going to do the line through them. But instead of linear regression, we go to quadratic regression. Alright, so highlight quadratic regression and hit enter, and that tells you these 3 points. Okay, so that means that our parabola, the graph of the quadratic, the equation would be a is 2, so 2x squared plus negative 6x, or just minus 6x, plus 5. So 2x squared minus 6x plus 5. Alright, that's the equation of the parabola that passes through there. And you could plug in any of those points and see that that is on this line, or that is on this parabola. Alright, now, just like we did linear regression, if we had more than 3 points, we could still come up with a quadratic. It just wouldn't hit them exactly like this one does. Now, find the quadratic function that models the annual income as a function of the average age. So these are going to be my x's, the ages, right? And it goes back to what we talked about in class. Find the quadratic function as a function. There's that phrase that lets us know who is x and who is y. So whatever comes before this phrase is your y. So annual income is y. The average age is what comes after this, so that's x. So age is x, and income is y. So again, I'm going to put it into my calculator. Alright, so there's all the data into my calculator, and still it wants a quadratic function that models this. So we're going to hit stat, we're going to come over to calc, and we're going to use quadratic regression again, so option 5. Alright, so option 5, hit enter. There's my numbers. Okay, now it's fine if these things, if it doesn't tell you, just to round it to, you know, the 10th or the 100th, so 2 decimal places. So our model is going to be negative 57.06 x squared plus 5,169.34 x minus 45,934.47. Alright, 2 decimal places this time because of the income being money. So I'm going to put that in there. Alright, and so there's our quadratic model that goes through here. Alright, now this second part says, does the model appear to be a good fit? Alright, what we need to do to come up if it's a good fit, if you see that, if you see that good fit on there, a good fit means something we call diagnostics on. And you look for a value we called r squared. R squared is the coefficient of determination, meaning it's the goodness of fit value. Right? Closer to 1, the better the fit. Alright, if it's close to 0, not a good fit. So let's go back to our data set, or sorry, back to our calculator. This time we're going to turn the diagnostics on. Now to do this, you need to press the catalog button. So the catalog button is down below. If you look at second 0, it says catalog. Alright, and notice you're in alpha mode. So alpha mode activates the letters that you see above the buttons. So we want D for diagnostics, and then just scroll down until you see diagnostics on. Alright, and there's diagnostics on, so I hit enter again, and it says done. Okay, and now when we run quadratic regression, it gives me that r squared value as well. Right, r squared is 0.9988. Right, very close to 1. So the answer to part B is yes, this seems to be a very good fit. So this is I'm going to write this as a good fit model. Alright, now just to illustrate that it is what we mean by a good fit, we literally mean that if we go into the stat plotter, so second y equals stat plot, like you're going to do a scatter plot, and we turn plot 1 on the scatter plot, and we hit zoom. Remember, zoom 9 is where we get to see our scatter plot. There's this thing. It already looks like a quadratic almost perfectly. And then if we run the regression again, this time if I do the quadratic regression, this time I'm going to tell it to graph it by pressing the vars button, scrolling over here to yvars, pressing enter for function, or just pressing 1, and then highlighting option 1 for y1. Right, and now it's sitting there waiting. I hit enter. Right, it gives me the same thing it gave last time, but notice now in y1 I have that quadratic model. And now if I hit graph, you can see it's a very good fit. It virtually goes through every point, except it kind of misses this highest point here, this peak. Alright, back to the question. Find and interpret the vertex of the graph of the function, this thing that we just came up with. So for part C, I'm going to go back to the calculator, and with the help of the calculator I can find the vertex of this thing. Now you want to hit trace. If you notice right now we're on the individual points. We're on the plot, L1, L2, the scatter plot. If I hit down, now I'm on the quadratic model. Okay, and I can go back and forth between them however I want to. Alright, now once we're on the quadratic model, alright, press second calc, and then let's find that maximum. That's where the vertex is. Alright, left bound means, you know, get close to where the vertex is, but press to the left. Right bound means get close to the vertex is, but press to the right. And then guess means just get close and hit enter. Alright, it runs through its little thing, and this is coming up with our maximum. So 45.29 for 71,136. Okay. Alright, so I went ahead and put that in there so we could reference back to it. But remember, what did we ask to do? Find and interpret the vertex. So this is the maximum. So the maximum median income is, this is the y value, this number, 71,136.00 occurs around age 45.29 years. Alright, so it's the maximum median income occurs at this average of these ages. Okay, that's what that vertex means. It's about when you maximize your income, basically. Alright, now the last thing in this this first type of modeling we do is it got several data points. So again, I'm going to put them all in there, but I want you to look real quick before I do. Create a scatter plot of the data points with x equal to the number of years after 1990. Sorry, I'm not going to write in 1992, 1993, 1994. I'm going to write in 2, 3, 4, 5, 6. Alright, so I've got all the data in here. Alright, again, 2009 represents 19, or is going to be represented by 19 in my scatter plot. So again, I want a scatter plot of the data points. So if I just hit second stat plot, plot one on again, like I had before, choose that scatter plot, and then zoom 9 is the zoom stat. There's what this scatter plot looks like. Oops, I still got my graph in there from the last problem. So there's our scatter plot. Okay. Now, if you have to do this by hand, for me on a test or a lab or something, once you've got your scatter plot, just hit trace, and then there's your points. And you can just plot those onto your graph one at a time like that. Okay. Also, if you have to do it for me by hand, there's your maximum height. Right, 11,567. So you can make your graph go up to like 12,000, but don't make it go up to like 100,000 or something, and your graph be all out of whack. All right, notice how your calculator, when you do the zoom stat, will always be tight around your data. All right, create a quadratic function that models the data using the number of years after 1990 as the input. So that just means what we did before. Quadratic regression. I'm going to, just like we have been doing, I'm going to tell it to store it in the y bars, just like we did last time. Alright, again, a very good model. And hit zoom 9 again, and then here comes our quadratic. Alright, just kind of misses it right there at the end. Alright, so that's what part B is asking us. It's asking us for this model. And again, I could write down, you wouldn't have to go this many decimal places, but I could round it like to 50.08 minus 327.94 plus 681.12, and that would be all I would need to answer that question. Alright, graph the aligned data and the quadratic function on the same axis. Does it seem like it's a reasonable fit? That's what we have right here. And yes, it seems like a very reasonable fit. Alright, use the model to estimate the number of scores in 2008. Alright, we got this many in 2008. Alright, that would mean 18. So if I press trace, trace allows me to predict with this curve that we made through here. So I'm going to press down to be on the curve. Alright, now I can just type in 18. Alright, 11,002 is where it estimates this height to be. Alright, is the estimate close to the actual number? 11,567. Now you may be thinking, well, that's 500 off. Well, but the fact that there's 11,000 numbers, 500 divided by 11,000 is nothing. It's like 4% error. Okay, so yeah, that's a good estimate. Alright, and then use the model to estimate the number of stores in 2012. Right, our model ends at 2009. 2012 would be 22 years after that. Now notice if I hit trace and I hit 22, oops, sorry, graph, if I hit trace and then I hit 22, Well, in the model, it tells me error invalid. Now the problem is 22 is not in my window on the graph. Remember, it goes up to 19. So I would need to increase my window to be able to go up to 22. So let's make it go up to like 25. And now hit graph. And now when I hit trace and I make sure that I'm in the actual function, right, not the points, now I can hit 22 and it gives me a point. Alright, so there's the point. Discuss the reliability. The trends seem to be good, so we would assume it's accurate, but because of that downward turn right at the end, we have to be a little bit wary of using that number.